All right, for tonight's extension, extra practice, example video, whatever, I'm going to do the odd problems off of the Your Turn homework that you have tonight. That means I'm going to be looking real closely at the even ones, so I'm just telling you that right now. So the first thing we're going to do is, again, when we're graphing a system, okay, I'm trying to find the values of x and y that will satisfy both equations if they exist. What this means is I got to graph both of these and see when or if or how they cross. Okay, so the first thing I'm going to do is I'm going to graph this one. I'm going to use two different colored pens because it helps me. If you want to, that's great. Okay, so the first thing I'm going to do is I'm going to look at the first equation, y equals x minus 2. So I know that in this case my slope is 1, so there's an invisible 1 there, and I know that my y-intercept is negative 2. So I'm going to put a point at negative 2, I'm going to rise 1 and run 1. Now, I'll be honest with you, the way I like to do this, rather than using a ruler, I don't know why, I like doing it this way because then I can see exactly where the points are. Now, it is theoretically possible that I might wind up with a point that is not anywhere on one of these lines, that's somewhere in between. But at least for now, I've got all the points that I could see plotted on here. All right. Now I'm going to take a look at the second equation. All right. The second equation is y equals 2x minus 3, which means that my slope is 2 and my y-intercept is negative 3. So I start by plotting a point at negative 3, and then I do my slope of 2 over 1. So I'm going to rise 2, run 1. Anytime I have a blue dot and a pink dot, I'm going to put an X. I rise 2, run 1. I think it's pretty obvious here that I'm not going to have any more overlap. Okay, so what I'm seeing is that if I were to connect these points, connect these lines all up, okay, then what I would have is two lines that cross in one place. That means we have one solution, and that one solution is at 1, negative 1. Okay, so there's one solution, and it is at the point 1, 1. I'm sorry, 1, negative 1. Okay? Let's try the next problem. All right, so this next one, number 3, we're going to do the exact same thing. Now, first of all, I'm hoping that you notice something about this that tells you right away what kind of lines you're going to have. I'm hoping that you notice that we've got 2 as our slope. That means we're going to have the same slope, means we have parallel lines. If we do it right, that's what we should see when we graph it. Okay? So for 2x plus 4, I have a slope of 2, and I have a y-intercept of 4. So I'm going to start at 4. I'm going to rise 2, run 1. Okay. And I'm just going to go ahead and go back in the other direction again, because I like to do it this way because it makes it really easy for me. A lot of times when I draw a line, what ends up happening is no matter how precise I try to be, I end up kind of getting a little bit off. So when I do it this way, I know that my points are exactly where I intended them to be. It doesn't take very long. It's actually a little zen because I'm just graphing the points and I'm thinking about my thinking and I'm all in my whatever. Anyway, I'm trying, but whatever. Okay, next one. Y equals 2x minus 5. My slope is also 2 over 1. My y-intercept is negative 5. Okay, so I'm going to start with a point in negative 5. Rise 2, run 1. Rise 2, run 1. Okay, and then I go back the other direction. Now, these look parallel, okay? If I connect these points up, they look parallel, but I can confirm that they're parallel by counting. So if you recall, on the lesson video, I said the way we know that two lines are parallel is if they're the same distance apart. So if I count, if I go between these 2 points and I count how far apart they are, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. They're 9 apart. If I pick another pair of points and I count vertically between them, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, they're both 9 apart. Since they're both the same distance apart, that means they'll never cross. Notice I didn't try to do some kind of crazy line going perpendicular to them because I don't know how long that is. I'm not trying to do any math. I'm just trying to count. So I counted how far apart they were. Since they're the same, so first of all, they have the same slope. Second of all, they're the same distance apart. That makes them parallel, and parallel lines have no solution because they will never cross. Remember, the solution is where they cross. Well, they're never going to cross because they have no solution because they're parallel. Okay? So that's why number 3 has no solution. All right, now this one is harder because with this problem, they're in standard form. Okay, so what have we learned when we have things in standard form? How do we graph them? Well, you can convert them into slope-intercept form if you want to, which is perfectly legit and valid, okay? So if we wanted to do it that way, I'll show you both ways. If I wanted to do it that way, I would say x minus 3y equals 0. And, well, I have x equals 3y. X over 3 equals y, which means y equals x over 3, which means y equals 1/3 x. Okay, because remember there's an invisible 1 in front of that, and then I can just pluck the x off and stick it next to it. Okay, so for this one, my slope is y equals 1/3 x plus 0. So my slope is 1/3. My y-intercept is 0. So I start at 0, 0. I rise 1, run 3. Rise 1, run 3, and then I can go back in the other direction as well. And again, I'm just continuing this pattern, all right? For the other equation, I can do the same thing. Let me get my other color. X minus y equals 4. Negative y equals negative x plus 4. Well, if I want this to be positive, then I got to flip the sign on everything. Y equals x minus 4. So I flip, flip, flip. So I flip this became positive, this became positive, that became negative. So now I've got this one. My slope is 1 over 1. My y-intercept is negative 4. So I'm going to start at negative 4. And I'm going to rise 1 over 1 until I hit an intersection. And I know it already happened there, but I don't know, I just like my stuff to be complete. Okay, so I can see that my intersection happened right there. I'm going to cross this. So I'm going to draw the lines there. And I can see that my intersection happened here at 6, 2. So it crosses at one point, and that point is 6, 2. Now, the other way that you could have done this is you could have used the cover-up method, but it's not as useful here, okay? It's fine for the second one, but for the first one, since it equals 0, I have negative 3y equals 0. That means y equals 0. So I should be using the blue here. And then I have x equals 0. So my intercept is right there. So that doesn't really help me because I don't have 2 points to make a line. If that happens again, what you do is you pick a point and substitute. Okay? So I can substitute in either a y or an x. Okay? It doesn't matter. If I put in a 1 for x, 1 minus 3y equals 0. 1 equals 3y. Y equals 1/3. I don't like that. But there is a point there. So I can do it that way. Maybe 3 is a better point for me to try. 3 minus 3y equals 0. 3 equals 3y. Y equals 1 over 3 up 1. So I can use those 2 points to make a line. And I could similarly do the same thing with this. Negative y equals 4. That means y equals negative 4, which is where I have my y-intercept. X equals 4. That means my x-intercept is 4. So I could have done this using the cover-up method as well. Okay? I'm going to tell you this one here. It's kind of tricky. It's the same process. Personally, I would convert them into slope-intercept form, okay, and see what you get. And then the other two are pretty straightforward slope-intercept form equations. If you got any questions, let me know.